How do you listen to music? Do you listen to it to match your mood? Or to change it? Maybe you dance to it. Or maybe just relax. It turns out we can see what happens in our brains when we listen to or play music. The waves go from this to this.
So as we're disengaging from the outside world and turning our focus inside, for example, the rhythms start to slow down. As we're planning to move, engage with the outside world, the rhythms, like for example here, start to speed up. So those transitions, those switches that we see here in real time, we believe they're some of the most fundamental properties of the brain. And if we understand them better, we can develop these targeted treatments for illnesses such as depression, anxiety, and others.
But let's back up. Whatever your taste in music, your brain reacts to it in a certain way. And watching what happens in the brain while it listens or plays may help unlock how the brain works. So, Doc, can you give me just a snapshot of your research and why music, really?
Brains are rhythmic. Brain's function is via electrical signaling, and those signals are rhythmic signals. Now, there is a strong parallel to music, which also has rhythm and structure. So we're taking here a radically different view by thinking about the brain and where those symptoms come from as an electric system.
Froelich says some brains are out of rhythm. He says that since brains are essentially electrical systems themselves, we can use technology to, let's say, bring that beat back. He says brains are like an electric symphony.
In fact, we can do something very similar to what the conductor would do in an orchestra. We can use what is called non-invasive brain stimulation, which is using minute amount of electricity to help the brain shape and crystallize those rhythms to help patients with psychiatric disorders.
He says by understanding the brain's electrical language, we can have what he calls a dialogue with it. And to demonstrate that, he invited violinist David Benet to help him. Benet runs Door to Door, a UNC hospital arts program that brings music to patients and staff as a form of therapy.
Now over you, it's going to fit really snug, kind of like a swim cap.
He's agreed to wear a headdress of sorts that will read the signals in his brain. Conductive gel is carefully inserted into each node on David's head, which takes some time, but it's important to have each node have a good connection to give a full picture of what's going on.
Okay.
It's seeing what the effects of the work that we do and the impact of the music to the people.
So what we're looking at here is a live stream from David's brain. And what we're detecting are tiny, minute electric signals. And as you see, there's a lot of rhythmic structure to it. Traditionally, we thought this is the brain thinking, but now we know this is the brain putting effort in to organize different parts of the brain as a function of whatever is going on in the moment.
I guess we'll have him play.
Right, yeah. Signals look good. We're ready to start. Yes.
Okay.
If you'd like to get started, David.
By recording how the frequencies are alternating, Froelich and his team can use this data to determine what kind of help is needed. In a clinical trial setting, the small electrical signals are sent to the subject, designed to regulate or steady them.
Yeah, so, relative to the size of my thumb.
More clinical trials are planned to review their version of a battery-powered portable device, a bit like this one. By attaching these clips to the earlobes for around 30 minutes a day, an individual would receive small electric impulses depending on their clinical needs.
Another great session.
Froelich is a trained electrical engineer and says what makes this research unique is that it's dependent on input from a wide range of disciplines to make it successful. One demonstration recently was born out of a partnership with Carolina Performing Arts.
Psychology is my background.
Co-research coordinator Savannah Finger here, in fact, volunteered to be part of it. She sat in front of an audience while music was being played for her, while her brain waves were displayed for all to see. Amanda Graham says simply that they are interested in how music impacts the brain and their audiences.
It's possible that our brain waves are moving in similar patterns, which brings us together as an audience, or could bring musicians together as an orchestra, which is interesting to think about, that this is a networked experience and not a solo one.
And it's that creative coming together of all this amazing talent, that trainees who are so passionate about advancing the development of new treatments in mental health, that make all of this possible.
Thanks for watching. If you enjoy science stories like this, like and subscribe for more.